Welcome back to the last section in 11.7 here. We are going to do just a couple more questions that are in your homework, and you'll see at least one question like this on the test. So the set of questions I'm going to look at will have the following directions. Find any x, and I'll just say x slash y-intercept. So it could be an x-intercept or a y-intercept. Or in the case of the x, it could be intercepts. Okay. And then it also specifies if no x-intercept exists, state this. And the procedure for this is really quite simple. Nothing is really complicated. So what we're talking about graphically when we're talking about an x-intercept and a y-intercept is if we're looking at the graph of the x-axis and the y-axis, what we're talking about when we're speaking about intercepts is if we have some type of parabola. It doesn't matter what it looks like. Let me see if I can find a green marker here. There are going to be certain points where the graph of the parabola or the quadratic equation is going to cross the axis. Now, it doesn't always cross the x-axis. It should always cross the y-axis, at least for what we're looking at now. So the points at which the parabola crosses the x-axis, these are what we refer to as the x-intercepts. And I hope that everyone can kind of see those okay. Yeah, it's a little light, but it should be pretty visible. At this other point here, we see on the graph where the graph is crossing the y-axis right here. We use kind of a little bit of a darker marker. We refer to this point that the parabola or the quadratic function crosses the y-axis. We refer to this as the y-intercept. Last semester, if you would take a Math 90, you would have been often asked to identify when a straight line crosses the y-axis, and that point would have been referred to as the y-intercept. In the case of most lines, they would cross the y-axis and they would cross the x-axis. The y-intercept is more commonly known because it's part of how we express a formula written in slope-intercept form, because we always refer to the y-intercept when we write it in that form. So how we identify what is the what values are the y-intercepts and what values are the x-intercepts is fairly straightforward to do. One thing to note here. Suppose, let's just say that this value is crossing over here. We'll just say it crosses at -3. And let's just say hypothetically, even though this isn't drawn to scale perfectly, we'll say that this crosses at the x value of 2. The way we'll express those points in terms of intercepts is that we'll know that the value of x is -3, but the y value is 0. So one x-intercept will be the value of -3, 0. Here, if the value of x is 2, we know that on the x-axis the value of y is 0, so we'd express the other x-intercept as the value of 2, 0. So again, we're going to take a look. So these 2 points here, -3, 0 and 2, 0, these represent the two values of the x-intercepts. Taking a look at this point here, the y-intercept, let's just say hypothetically this is crossing at 4. So I know it's a little hard to see, so we're going to say that this is the y value here is 4. Well, if we look at the origin we want to get here, we don't go to the left, we don't go to the right, so the x value here is going to be 0, but the y value is going to be 4. So the y-intercept is going to have a value of 0 and 4. So we want to kind of just make kind of a generalization for when we're finding x-intercepts and y-intercepts. So when we're finding x-intercepts, when we have them, we don't always have them. Sometimes we may only have one, sometimes we may have two. Usually we'll have two. It's unusual to have one, and it's not unusual necessarily to have none. But when we have x-intercepts, note that there's going to be some value of x here, but that the y value is always going to be 0. And this will be the value or values that we're looking for. So just note that for the x-intercept, the y value is going to be 0, because the y value on the x-intercept is always 0. For the y-intercept, and at least at this level when we're graphing quadratic functions, there will always be one y-intercept. When we graph the y-intercept, we'll notice here that the x value is equal to 0. And then we just simply have to identify at what value of y this crosses. So this is an important concept. So at the x-intercept, we can know that y is equal to 0. At the y-intercept, we can identify that the value of x is equal to 0. That's always going to be the case. We're going to utilize this property here to carry out the work in a few problems we have in this section. So we're going to go ahead and let's take a look at question 50. Here we're asked to find the x-intercepts and the y-intercept. If there are, there should be a y-intercept, but maybe there will and maybe there won't be any x-intercepts. So let's go ahead and take a look. And we have the first function. F of x is equal to x squared plus 5x plus 2. So one thing I do know, that if I want to find the x-intercepts, I know that the value of y is 0. So for the x-intercept, and I'm just going to type this in x, not type, but write, for x, int, for the x-intercept, I know that y is equal to 0. So what I'm going to do is go ahead, or for f of x, I'm going to put 0 in place of f of x, or 0 in place of y. I'm going to write 0 equals x squared plus 5x plus 2. So as I look at this here, I wonder, is this going to cross? Well, is this factorable? It's not real factorable. I mean, you could try doing it completing the square, but I would suspect most of you are probably going to use the quadratic formula. So we want to find the values of x for which y is equal to 0. So that's what we're going to do. We're going to go ahead and do that. So we have a of 1, b of 5, c of 2. So x will equal negative, and this is going to be 5 plus or minus the square root of 5 squared minus 4 times 1 times 2. I'm running out of room here. Let me try this one more time. So if x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 5, or times 2, excuse me. So when I do this here, I'm going to put this over 2 times 1. So this is going to give me x equals negative 5. We'll just kind of simplify this here because the focus isn't simplifying this, so the focus is on getting these values. So this is going to be 25. This will be 25 minus 8, so this is going to be radical 17, and that's going to be over 2. So notice here we have two values of x. So we've got x equals negative 5 plus radical 17, okay, over 2. And then we have x equals negative 5 minus radical 17 over 2. So we're going to have 2 points for the x-intercept, and even though these points aren't necessarily elegant, they may not be easily found, but the x-intercepts are going to be negative 5 plus radical 17 over 2, 0, and then negative 5 minus radical 17 over 2, 0. Noting that from what we have up here, that we'd have found the x values that make this true. If you put these on a calculator, you will get these down to some approximate decimal, never an exact value, because the value of radical 17 is an irrational value. So we're going to go ahead now and we're going to take a look at the next part of this here. If we want the y-intercept, this is where we're going to let x equal 0. So this is the one part that's usually is easier. So if we let x equal 0, let's go ahead and put y in place of f of x. So we have y equals, let's go ahead and write this again. Since x is equal to 0, I'm going to write y is equal to 0 squared plus 5 times 0 plus 2. Well, that's going to be y is equal to 0 squared is 0. 5 times 0 is 0 plus 2. And y is simply going to equal 2. for the y-intercept. So the point that we're going to obtain for this, for the y-intercept, is going to be the point 0, 2. So in this first problem here, we have the x-intercepts, and here we have the y-intercept. I should make one note of this, and I'll take the opportunity to do it on this page, is that in MyMathLab, I would accept these as answers on a test when you're identifying the x-intercepts. However, on MyMathLab, they may want you to break these up. So we're just going to look at another way of writing these. They may want it as negative 5 over 2 plus radical 17 over 2, comma, 0. And then this is going to be negative 5 over 2 minus radical 17 over 2, comma, 0. So notice here all I'm doing is I'm splitting up that fraction into two separate parts. I'm not fussy about it one way or another, but just know that MyMathLab may be fussy about the way this is expressed. So if you're having difficulty with that, that could be the source of your difficulty. So let's go ahead and take a look at a few other problems here. Let's start looking at 52, where we're going to have g of x equals x squared minus 6x plus 9. So if it helps, because we're looking at x-intercept and y-intercept, let's go ahead and write this as y equals x squared minus 6x plus 9. Let's go ahead and we're going to find the x-intercepts first. And remember, at the x-intercept, y is equal to 0. So since y is equal to 0 for that, I'm going to go ahead and put 0 for y here. So I have x squared minus 6x plus 9. Fortunately, in question 52, I think we have one that is much simpler to factor. So let's go ahead and we're going to factor this in for this one. We're going to get x minus 3 times x minus 3. That's going to equal 0. And when we get something like this and we can factor this quite simply, then what we're going to get now is, well, let's see, we're going to set x minus 3 equal to 0, x minus 3 equal to 0. And of course this is the same thing, you just add 3 to both sides. This is one of those instances where this is a double root, where the parabola is going to come down and just touch the x-axis. It's not going to pass through it. It's only going to come down at x equals 3. And it's going to cross this. So let's just take a look at what the graph of this looks like, so to kind of understand this a little better. So the parabola in this case is going to come down where x is equal to 3. It's going to cross somewhere here. And it's kind of come down a little bit. And yeah, now this isn't a perfect parabola, but so coming down and actually, yeah, let's go ahead and just touch it. So it's not going to cross the 2 points, it's going to come down, kind of kiss it, and then go back up and away again. So we have one x-intercept, and the value of that's going to be 3, 0. So 3, 0 represents the x-intercept. For the y-intercept, remember, for the y-intercept, the value of x is equal to 0. So what I'm going to do is I'm going to write the original equation down for the parabola, or the original quadratic equation, and I'm going to go ahead and put 0 in for x to see what value I get for y. So here we're going to have y is equal to 0 plus or minus 6 times 0, which is 0. 0 minus 0 plus 9, y will equal 9. So if y is equal to 9, the point for this is 0, 9. So here's going to be the point on the y-axis of 0, 9. And this is the value of 3, so the point here is going to be 3, 0. This is the value of 9 here, so the point is going to be 0, 9. So we have our y-axis at 0, 9. We are not y-axis, our y-intercept at 0, 9. And then we have our x-intercept at 3, 0. So that concludes doing question 52. I'm going to go ahead and do a couple other questions to hone your skills on this a little better. So let's go ahead and take a look at 54. 54 is a little bit unusual, but nothing that can't be done. So for 54, we have the function f of x is equal to x squared minus 7x x. I say this is a little unusual because even though this is one that can easily be solved by factoring, we don't encounter this change in factoring or this type of factoring much. So I'm going to go ahead and replace f of x with y. And write this as x squared minus 7x. And for this one, again, I'm going to want to find the x-intercepts first. And for the x-intercept, the value of y is equal to 0. So I'm going to go ahead and put 0 in for y. So the first type of factoring I could do for this is I can factor out the greatest common factor, and that's going to be x times, and that'll give us x minus 7. Once I do that, I can set each of these factors equal to 0. And x equals 0 is done. So that's going to be 1 point this crosses. And then for x minus 7 equals 0, I'm going to add 7 to both sides. And that'll give me x is equal to 7. So if x is equal to 0 and x is equal to 7, this is going to give me two intercepts of 0, 0, and 7, 0. So what this is looking like graphically is we have a parabola doing something like this. So here's a point 0, 0. Here is the value of 7. So this is going to be 0, 0. This is going to be 7, 0. So these represent our two x-intercepts for this. Now, some of you who are astute may note that, hey, this is also crossing the y-axis at this point, and that would be correct. And as it turns out, the x-intercept would turn out to be the y-intercept too. So the y-intercept is also 0, 0. But let's say you couldn't pick that up right away, and let's say you just had to test this out for yourself because you didn't believe it. Let's go ahead and write down y equals, kind of put that together here. Y is equal to x squared minus 7x. Well, remember, at the y-intercept, x is equal to 0. Let's go ahead and put that in now. So y is equal to 0 squared minus 7 times 0. Then that's going to give me y is equal to 0 minus 0. Well, 0 minus 0 is still 0. So that turns out to also be the case. So we get the point here, the value of y being 0, and of course the value of x is 0. So we have here the x-intercepts of 0, 0, 0, and 7, 0. And by the way, anytime you get a point parabola going through this, that will serve as the x-intercept and the y-intercept. So this is the x-intercept and the y-intercept. So that point functions as both. Let's go ahead and take a look at just one or two more questions. So in case you see any surprises in this that you may not like, that this won't throw you off. Let's go ahead and take a look at 56 now, and then we'll take a look at 60. So 56, we have h of x equals negative 2x squared minus 20x minus 50. Okay, so there is some work that can be done with this. The first thing that should be noted here is that this is going to be an upside down parabola when it's graphed as is because we have a negative a coefficient here. So when we're looking at the parabola, we're going to notice that the parabola is going to be some kind of a frown. Let's go ahead and change that to a y. So we have y equals negative 2x squared minus 20x minus 50. It's important to note this because later we're going to be doing some factoring and we're going to be factoring that negative out. And that's going to be work we use to find the x-intercepts but not necessarily characterize the shape of the graph. So let's go ahead and we're going to find the x-intercept. And remember, the x-intercept y is equal to 0. So I'm going to go ahead and put that in now. Remember, it's the original parabolic function or the original quadratic function which causes the shape of the graph, because what I'm going to do now is I'm going to go ahead and factor out negative 2, and that's going to give me x squared minus 10x plus 25. And that's still going to equal 0. So I'm going to go ahead and I'm going to divide by 2, or divide by negative 2. That's going to get rid of that there. And that'll give me 0 is equal to x squared minus 10x plus 25. So when we do this, and we see this is very nicely factorable, this is going to be x minus 5 times x minus 5, which is equal to 0. I'm going to set each of these equal to 0. And here I'm going to have x is equal to 5, x is equal to 5. So here's another one of those examples where we have a double solution for this. Let me just set that equal to 0 here. I didn't do that. But the parabola is going to be upside down. It's going to come up where x is equal to 5, and it's going to be a little more narrow because it has a coefficient of 2. And it's going to come from the bottom because the coefficient on the a term is negative. I come up at 5, and it's going to do this. So at the value of 5, this is going to be the value of the x-intercept at 5, 0. That also is likely to mean that somewhere way down here, this graph is going to cross the y-intercept. And that's a value we want to know. We know that's going to be 0 something. Although some of you may be seeing a pattern to identifying this quickly. We'll go ahead and go with the procedure on this one. So now we want to find the y-intercept. So for the y-intercept, we're going to let x be equal to 0. So we'll write the original function again. Y equals negative 2x squared minus 20x minus 50. So y will equal negative 2 times 0 squared minus 20 times 0 minus 50. So y will equal, well, let's see, negative 2 times, well, 0 squared is 0 times negative 2 is 0. Negative 20 times 0 is 0, and then it'll be minus 50. So y is going to equal negative 50. So here, our y-intercept is going to be 0, negative 50. So our x-intercept is 5, 0. Here our y-intercept is 0, negative 50. You notice here that's quite far down. The reason this goes down faster is because this is a coefficient of 2. Remember that the coefficient higher than 1 is going to make the parabola much more narrow, which means it's going to go down faster. If this is a value of less than 1, it's going to make the parabola wider, which means it will probably cross, earlier than we expected across the y-axis. Let me just do one more thing. Let me make sure I go ahead and label these just to be consistent in my work here. So I don't have to label this x again. But here we have a x-intercept of 5, 0 and a y-intercept of 0, negative 50. Let's take a look at one last example and kind of see what happens with this. So this is going to be the last example we're going to look at in section 11.7. So it's going to be number 60. And this is going to be f of x is equal to x squared minus x plus 2. Well, I mean, that looks like a pretty simple, innocent, nice little question there. So let's go ahead and let's replace f of x with y. And again, we want to find the x-intercept. So in the x-intercept, y is going to equal 0. So I'm going to replace y with 0 and set that equal to x squared minus x plus 2. Well, when you try to think about how we can factor this, I mean, we could have negative 1 times negative 2 is 2, but that adds a negative 3. We could take positive 1 times positive 2, that would be 2, but it adds to positive 3. Doesn't look like factoring is going to save the day on this one, so I'm afraid we're going to have to refer to our good friend the quadratic formula on this. So we're going to be x equals negative b, which is going to be negative 1 plus or minus the square root of b squared, is going to be negative 1 squared minus 4 times 1 times 2, and it's going to be over 2 times 1. So notice here I'm not going through all the steps of doing this because I did that in the earlier sections. I'm kind of cutting to the chase here because the focus of this is a little bit of a different skill. So x is going to equal 1 plus or minus, well, negative 1 squared is 1. But then we have 4 times 1 times 2 is going to be negative 8. So 1 minus 8 is going to be radical negative 7. And that's going to be over 2. So in this case here, I need to be splitting these up because since we have a negative 7 under a radical, we're going to have to put this in a complex form because we're going to be getting an imaginary number in this part here, which is going to make the solutions here complex. So we're going to write down x is equal to 1 over 2 plus or minus, and this is going to be radical 7 over 2i. We leave the I separate as part of the fraction. And if you're going to write this in two parts, we could say that x is equal to 1/2 plus radical 7 over 2i. And then over here, x will equal 1/2 minus radical 7 over 2i. So those are our two solutions for x. However, these are imaginary numbers. And what we are saying here is that when we get an imaginary solution, there are no x-intercepts. So because these are imaginary, there are no real places where this crosses the x-axis. So for the x-intercept, there are none. Does this in fact cross the y-axis? So let's go ahead and see. So for that one, we're going to do the y-intercept. And for the y-intercept, we're going to let x equal 0. And we're going to go ahead and put that in. So let's rewrite the function again. When we do that, we're going to get 0 squared minus 0 plus 2. And, well, let's see. 0 squared is 0 minus 0 plus 2. Well, yeah, it does appear to cross at 2. So our y-intercept is going to be 0, 2. So what would the graph of this look like if we had no x-intercepts? Well, the graph of the parabola simply looks like this. So let's take a look at this. Well, we do know because the a coefficient is 1, that's going to be a normal kind of shaped parabola. We also know it's going to cross at y equals 2. So if this is y equals 2 here, if this is the point 0, 2, parabola's going to probably do something like this. And then soon after going down, it's probably going to come back up again. And notice here that this type of parabola, in fact, does not at all come down to touch the x-axis. If you were to rewrite this and to put this in the a times x minus h squared, the quantity squared, plus k form, you would note that the vertex would be somewhere at let's see, negative b over 2a. The vertex would be somewhere like at 1/2 something. So you can figure that out. But so this is the general shape of the graph, and note it does not cross the x-axis. So not every parabola is necessarily going to have x-intercepts. Sometimes it will have only one intercept, and usually it will have two. But these are the possible outcomes. So, but usually it's going to have some type of y-intercept. So that wraps up our lesson for section 11.7. I will see you in class.